All right, good morning. Hope everybody's doing well. Okay. Last time, we'll say, Monday. It seems more correct. We talked a bit about that RREF that we've kind of used in our calculator before, but what does that actually mean? It stands for reduced row echelon form. And we talked about how to get there by using Gauss-Jordan elimination. And so we're just going to continue that on today. We did a bunch of 2x2 matrices on Monday, and so now we're going to bump it up and actually do some 3x4 and some 4x5 matrices. And it's going to be a lot of fun. I'm going to have fun. Let me just pull this up. Woo. That's the kind of enthusiasm that I'm looking for here. Thank you. That's exactly what I needed. Okay. Hold on. There's my mouse. There we go. Kyler, how you doing, man? How's the morning treating you? Okay, so if we're starting off, if we have a system of equations, then the first thing that I want to do is just put it into a matrix, right? So I'm just going to take all my coefficients, 2, -3, 1, 2, -4, 8, -4, -4, 7, 7, 7, 28. All right, I'll draw my line here. So now this is called an augmented matrix. This just tells us, that line just basically represents the equals sign that separates the two sides of the equation. Just woke up. I'm pretty tired. I feel you, man. I woke up later than I usually do. So, I woke up around like 7:30, but usually I wake up long before that. So, I'm kind of in that zone as well. I feel you. I got my tea here. We're geared up, ready to go. We can get through this. All right, so our first goal is we want to somehow get this top left, this A11 spot to be a 1. Right, using our various row operations. So one thing that kind of leaps out at me here is that when I look at this bottom row, all of these numbers are divisible by 7. That's kind of interesting. So what I'm going to do is take row 3 and divide it by 7. So these top rows will stay the same. 2, -3, 1, 2, -4, 8, -4, -4. 7 divided by 1, 1. 7 divided by 7, 7 divided by 7, 1. 7 divided by 7, 1. 7 divided by 7, 1. 28 divided by 7, 4. Okay, so now, down here in this spot, I see I have a 1. Well, I'd really like for that 1 to be up here in this top left corner. Well, we know that one of our operations we can do is just switch rows. So let's switch row 1 and row 3. Pretty neat. So now row 1 is 1, 1, 1, 4. Row 2 stays exactly the same. Or wait, oops. I'm looking at the wrong thing. And row 3 now becomes 2, negative 3, 1, 2. All right, so my first goal has been achieved, which is get this number to be a 1. Okay. So after that, now I want to clear everything below the 1. So I want to turn this into a 0. I want to turn this into a 0. All right, so when we start clearing, now is where we want to use the adding multiples of one row to another row. So what do I need to add to negative 4 to make 0? 4. Great. So let's do 4 times row 1 plus row 2. Row 1 is going to stay the same. 1, 1, 1, 4. Row 2 will change, however. So 4 times 1 is 4 plus negative 4, 0. 4 times 1 is 4. 4 plus 8 is 12. 4 times 1 is 4. 4 plus negative 4, 0. We got another 0. It's kind of nice. 4 times 4 is 16. 16 plus negative 4, 12. So it's 0, 12, 0, 12. Interesting. And row 3 stays the same. Okay, so I have my 0 right here below the 1. Now I want to create another 0 below that. So again, we're going to use the 1 to use this to make this 0. So what would I need to add to 2 to make 0? Negative 2. All right, so let's do negative 2 times row 1 plus row 3. First row stays the same. 1, 1, 1, 4. Second row stays the same. 0, 12, 0, 12. But now this third row will change. So 1 times negative 2 plus 2 is 0. 1 times negative 2 is negative 2 plus negative 3 is negative 5. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. All right, so our first really large goal has been accomplished now. Not only did we get a 1 in the top left corner, we cleared everything below it, so we have zeros below it. So now the next step is, how can I turn this into a 1? All right. Well, again, let me look at this entire row. Just like over here, all of these were divisible by 7, so I times 1/7. This whole row is divisible by 12. So let's multiply that entire row by 1/12. So 1/12 times row 2. So row 1 stays the same. 1, 1, 1, 4. Row 2, 0 times 1/12 is 0. 12 times 1/12 is 1. 0 times 1/12, 0. 12 times 1/12, 1. And row 3 stays the same. Awesome. So I got the 1 right here that I wanted. Now I need to clear the stuff below it. So I need to make this -5 0. Okay, so kind of the big thing in the pattern that we use is once I get a 1 right here, then I'm using that 1 to make this 0. And I use this 1 to make this 0. All right, so now we're kind of going to do a similar thing. So now that I have a 1 right here, I want to use this 1 in order to make this -5 0, right? So it's like once we move over a column and make a 1 on that next column's diagonal, I want to use that thing to then create 0 in the other ones. Okay. So what times -5 makes, or sorry, what added to -5 makes 0? Well, +5. So let's use 5 times this +1 added to this. So 5 times row 2 plus row 3. Row 1 stays the same, 1, 1, 1, 4. Row 2 stays the same, 0, 1, 0, 1. Row 3 will change, so 5 times 0 is 0, 0 plus 0 is 0. Great. Now we want to make sure that we're doing that because we don't want to mess up. Our first column here is perfect the way it is. We don't want to do anything that's going to change that at all. Right? 1, 0, 0, that's part of what we want. So notice that we didn't change that. That's still staying 1, 0, 0. All right, always make sure if you do a row operation, did you mess up your previous work of making a 1 or a 0 somewhere? Hopefully not. Okay, so 5 times 1 is 5, added to -5 is 0. 0 times 5 is 0, 0 plus -1 is -1. 0 times 1 is 0, or sorry, 5 times 1 is 5. 5 plus -6, also -1. Okay, interesting. Okay, so we've done our first 2 main goals. First column, 1, 0, 0. Second column, 1, 0. Now notice in the second column there's this 1 up here above it, but remember from our steps from earlier, or Monday, that's fine. We're just worried now, right now, 1 on the main diagonal and then 0's below it. We'll go back and worry about the above stuff later. Okay. All right, so now I really want this to be a 1. It's already a -1, so it shouldn't take a ton of work to get this to 1. Right? And it won't. How do I turn -1 into +1 using one of my row operations? That would be really easy. Let's just multiply row 3 by a negative. So row 1 stays the same. Row 2 stays the same. Row 3, 0 times negative is 0. 0 times negative is 0. -1 times a negative is +1, and -1 times a positive, or sorry, -1 times a negative is also +1. All right. So I have this. So this is now in row echelon form, not reduced row echelon form, just row echelon form. And so we got a 1 and made all the stuff below that 0. We got a 1 and made all the stuff below that 0. And we got a 1. There's nothing below it to make 0. If there was, then we would. So we did our first progression of left to right. Now we're going to go back and do right to left, okay, to worry about the above stuff. So now, again, we went this column, this column, this column. So now we're going to start here clearing the above stuff. So I want this to be 0 and this to be 0. Well, check it out. This one's already 0. So wow, I'm already done with that step. So let's just make this 0. Right? And we're going to use our 1. Right? So what added to 1 makes 0? Negative 1. So negative row 3 plus row 1. Let's start on this far column. 1 times negative is negative 1. Negative 1 plus 4 is 3. 1 times negative 1 plus 1 is 0. Negative 0 plus 1 is 1. Negative times 0 plus 1 is 1. Row 2 stays the same, 0, 1, 0, 1. Row 3 stays the same, 0, 0, oops, not 0, 0, 0. Oh, come on. Okay, so now we're doing our backwards progression. So I got a 1 and all zeros above it. So now we'll use this 1 to clear this. So what added to 1 makes 0? Again, a negative. So let's use negative row 2 plus row 1. Let's put row 3 here. Row 3 will stay the same. Row 2 will stay the same. So the thing that's changing is row 1. So negative 1 plus 3, that's 2. Negative 0 plus 0, great, that's still 0. Negative 1 plus 1, 0. Negative 0 plus 1 is 1. All right, and take a look here. This is now in reduced row echelon form, right? Where it's it's 1s along the main diagonal, zeros everywhere else on this side, and then we have our values on the right side of the bar. And so what this means is we now just know our answers. Right? So the first row represents kind of like my first variable, x. Right? I have 1x, 2, so x equals 2. I'll just make my way down. Y equals 1, so from this next row, because I have 1 over here in the right column. And then the next row down representing z, well, I have a 1 down here, so z equals 1. So really, we're just kind of looking at this is like our answer column now. So we have 2, 1, 1. There we go. We did it. It's a lot of numbers. It's a lot of places to go wrong. A lot. Only a little painful, true. See, now here's the most painful part whenever you're doing these. You'll get all the way through here, and then you'll end up with like something that doesn't make sense in like one of these last few steps. and you're like, what? Did something go wrong? Did I mess up something? And you'll realize that actually in this first step, whenever you made the matrix, instead of +8, you accidentally put a negative. And so you'll have to go back to the very beginning and do the entire thing over again because you just forgot to write something down wrong. Or over here on this line, you, instead of putting 4, you just accidentally put 14 because you just, you're writing a lot of ones, or just something stupid like that, that in one of your first steps will be like, oh, that's where I went wrong. And that will actually be soul-sucking. That's like, after this class on Monday, I have calculus after this. I went to go teach calculus, and I taught the whole calculus block. It was like an hour long. It was really, like, calculus classes are always long. It's like an hour long, and we're just doing, I was doing like a bunch of AP review questions. And I was like, man, chat's kind of quiet today, but I was like, all right, sometimes they're quiet, whatever. I go to the very end and I ask some question, like directly to them, not just like an open question to myself. Like, I directly asked the class a question. No response. I was like, well, that's weird. Pull up my streaming screen. I never clicked start streaming. Oh, you remember? Someone tell you this? And I almost cut my entire face off right there. It was awful. Oh. All right. Use Gauss-Jordan elimination to solve the system of equations. So, I now have 4 equations, and I have 4 variables. So this is going to be a bigger matrix. Jeez, they were asking me why you weren't on. I thought I was on. I sure thought. I'm always writing crooked. I need to fix that. I'm working on it. It's better. Oh, wow, it's going to take a while. Sure is. Okay, so notice, since I have 4 variables, now I have 4 columns on this left side. So I have my W column, I have my X column, I have my Y column, and I have my Z column. All right, just like when we do this in the calculator, all right, we have to have zeros to represent placeholders of things. So 2x plus 2z, when I actually think about that, I need to think about it in terms of w, x, y, z. So that's actually 0w plus 2x plus 0y plus 2z equals 8. So that I have that 0, 2, 0, 2, 0, 2, 0, 2. All right, so you still have to have a placeholder for every variable, even if it doesn't have that variable in the equation. All right, just put a 0. So this will take a while. I did I did give us a head start. All right, and that's this. My first goal, make this first top corner a 1. All right, I already have that under control. After that, I just want to clear everything below it. 0, 0, 0. Okay, so I already have 2 of the zeros that I need. I just need to make this 3, 0. All right, so we're going to use the 1 to make this a 0. So what plus 3 makes 0? Negative 3. So negative 3 times row 1 plus row 4. Now all these first rows are going to stay the same. 1, negative 1, negative 1, 1, 0, 0, 2, 0, 2, 8, 0, 0, negative 1, negative 2, negative 8. Okay, now row 4 is the thing that's actually changing, so let's actually do the math. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Negative 3 times negative 1 is positive 3. Positive 3 plus negative 3, well, that's also 0. Great. Negative 3 times negative 1 is positive 3. Positive 3 plus negative 2 is 1. Negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. Negative 3 times 0 is 0. 0 plus 7, 7. That sucks. Let's try that again. Tiny bit better. I'll take it. Okay, so we've reached our first main goal of make that first column a 1 and then all zeros below it. Okay, so my next main goal is how can I make this a 1 and everything below it 0? Well, it looks like I've already got some of the zeros below, so I need to turn this into a 1. Well, again, take a look at this entire row. All of these things are divisible by 2. So let's take row 2 and divide it by 2. So multiply by 1/2. 1. All the other rows will stay the same. So first row stays the same. Second row, 0 times 1/2 is 0. 2 times 1/2 is 1. 0 times 1/2 is 0. 2 times 1/2, 1. 8 times 1/2, so 8 divided by 2 is 4. Row 3 stays the same. So I'm lucky. First row, 1 zeros. Second row, 1 zeros. Right. Starting from the main diagonal. So I don't care about the negative 1 that's above it right now. I'll worry about that later. But 1 zeros below it, 1 zeros below it. Now this was easier for me because there were already this 0 and this 0 here. We didn't have to do anything to get that. It just kind of happened. Usually we might have to do something to make that happen, but for right now we're okay. So now let's move to the next spot. So now I want this to be just a 1 and then zeros below it. Hiccups. So how can I turn this into a 1? Well, it's already a negative 1. So let's just take this row and multiply it by a negative. So let's just do a negative times row 3. All other rows stay the same. So row 3, 0, 0, positive 1, positive 2, positive 4, and row 4 stays the same. Okay, so I got the 1 right here. Now I just need to make the stuff below it a 0. So I just have to worry about this 1 now in row 4. How do I create that? Or how do I make that into a 0? Well, what added to 1 makes 0? Negative 1. So let's do negative row 3 plus row 4. So first 3 rows will stay the same. So I'm just going to copy those down. Okay, so let's actually, oh, I didn't write the thing. So negative row 3 plus row 4. Zero, because negative 0 plus 0 is 0. Negative 0 plus 0, also 0. Negative 1 plus 1, 0. Negative 2 plus 1, negative 1. Negative 2 times 4 is negative 8. Negative 8 plus 7, negative 1. Okay, so now I want this. I got 1 zeros, 1 zeros, 1 zeros. So now last thing is I just want to turn this into a positive 1. Well, if we want to turn something positive or negative, let's just multiply that whole row by a negative. So that's just going to turn this. So if I multiply this row by a negative, it's just going to turn this positive and turn this positive. So everything else is staying exactly the same. You'll notice in these problems a lot of it is just copying down the same crap over and over again without actually doing anything to it. Oops, not negative. So we've completed now just normal Gaussian elimination. All right, of getting the main diagonal to be 1s, all the stuff below it 0. But now to do reduced row echelon form, Gauss-Jordan elimination, we need to now clear the stuff that's above it as well. Okay, so now instead of moving left to right, we're going to move right to left. So we're going to use that bottom right 1 to make zeros of all the stuff that's above it. So 1, what would I need to add to 2 to make 0? Negative 2. Okay, so let's do negative, oops. Let's do negative 2 times row 4 plus row 3. First row stays the same. Second row stays the same. Row 3 will change, so 0 times negative 2 plus 0 is 0. 0 times negative 2 plus 0 is 0. 0 times negative 2 plus 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. And row 4 stays the same. All right, we've got the 0 here. Now let's get the 0 here. So what added to 1 makes 0? Negative 1. All right, so again, we're still using this bottom one right here. So negative row 4 plus row 2, so that I can turn this into a 0. First row stays the same. Haven't done much with the first row since that very first step. All right, so row 2 is changing. So negative 4 plus row 2. So it's negative 0 plus 0, 0. Negative 0 plus 1, 1. Negative 0 plus 0, 0. Negative 1 plus 1, 0. Negative 1 plus 4, 3. Row 3 stays the same, row 4 stays the same. So again, I know a lot of it is writing the same things over and over again. I see people try to do multiple steps in one matrix. Like going from here, they'll try to do this step and this step at the same time to change both of these rows. You can do that. I would not recommend it at all. 9 times out of 10, it's already easy enough to make a mistake on this. 9 times out of 10, if you try to do multiple steps in one, you're going to screw up something tiny. It's going to ruin the rest of your problem. So I would not recommend it. You can, but you're probably just making more work for yourself because there's something small that you're going to miss. All right, so let's get a 0 here now. So what added to 1 makes 0? Negative 1. Great. So negative row 4 plus row 1. All right, row 1 is finally changing. Negative 0 plus 1, 1. Negative 0 plus negative 1, negative 1. Negative 0 plus negative 1, negative 1. Negative 1 plus 1, 0. Negative 1 plus 0, negative 1. Aha, so it didn't change much, but it changed. And all this stuff, row 2, row 3, and row 4 stay the same. Okay, so now working backwards, doing our above steps, we now have a 1 and all zeros above it as well. So now we move over to the next column. Now there's already a 1 there. We already got that. So now let's just make this stuff 0. Well, we already have a 0 here. Again, thank God. So let's make a 0 here. What added to negative 1 makes 0? Positive 1. Well, we already have a positive 1, so I don't even need to do anything. I just need to add, I need to do something, but I don't need to multiply by any coefficient of any kind. I can just do row 3 plus row 1. Don't need to multiply this by anything because 1 plus negative 1 would already make 0. All right, row 3. So row 3. So 0 plus 1, 1. 0 plus negative 1, negative 1. 1 plus negative 1, 0. That's the whole point. 0 plus 0, 0. 2 plus negative 1 is 1. Make this a little bigger. Row 2 stays the same. 0, 1, 0, 0, 3. 0, 0, 1, 0, 2. Row 3 stays the same, and row 4 stays the same. 0, 0, 0, 1, 1. We're so close. We're almost there. we've got our 1 and zeros. We've got our 1 and zeros. Last step is to get 1 and 0 above it right here. Now we already have the 1. Let's just make this into a 0. And again, what added to negative 1 makes 0? Well, just positive 1. So let's just do now. Again, I don't need to do any multiplying. I can just do row 2 plus row 1. 0 plus 1, 1. 1 plus negative 1, 0. 0 plus 0, 0 plus 0, 0 and 0. 3 plus 1 would be 4. And then all these other rows will stay the same. 0, 1, 0, 0, 3. 0, 0, 1, 0, 2. 0, 0, 0, 1, 1. This is now in reduced row echelon form. So now I should see that my right column here is all my answers. So W is 4, X is 3, Y is 2, and Z is 1, or 4, 3, 2, 1. It did it. Now this is a super long example. But just getting the practice of illustrating how we go about doing this. But it did take a lot of work, a lot of numbers. Yeah. The good news is you can always check your work with your graphing calculator, because I taught you guys how to do RREF, reduced row echelon form, for a matrix on your calculator, so you can know what the answers are. Or we could just like do it on the calculator. You could. But we also need this practice for other things, not even just for solving it. We're going to do other things that the calculator couldn't do for us. All right, check this bad boy out. Now that's a doozy. 1, 2, 3, 4, 5, 6 rows, 7 columns. Be super fun. I have a different calculator. Oh, your calculator can do those things? Is that what you're saying? Or are you telling me you don't know how to do it on your calculator? Now, I'm not going to sit here and do this. I'm not going to make you, I'm not even going to say that you should do this either, because I don't think you should do this. But just showing that this works for more and more. It doesn't matter the size of the matrix. This always works. And so a really interesting application of this. So this is when you talk about matrices and solving and systems and Gaussian elimination and things like that, you're actually talking about something that's called linear algebra, which if you go into any math or science related field, you probably have to take a class that is purely called linear algebra. A lot of matrices stuff. And if you go into any type of physics or engineering, matrices, you're going to use them an insane amount, right? Or vectors, which is a type of matrix. But what's super interesting about the Gauss-Jordan elimination and the row operations and stuff, is actually because of Google. You know, when you type something into Google, and when you type something into Google, it's pretty much like almost guaranteed that the thing you want is actually one of those like first 3 links that Google gives you as options, right? And more often than not, that very top link that they show you is exactly what you wanted, right? That's pretty crazy when you think about it, that you can just type in a couple words and Google can sort through all the web pages that are on the internet and decide, oh yeah, this is the one that they want. And so what a lot of people think is like that Google just scans like titles of web pages, right? Like, do the search words that you put in match the title of this web page, and they return that. That's not actually what it does. Okay, it's related to what it does, but Google has an algorithm for its page rankings, how it determines this is the first link I'm going to show this person, and then I'm going to show this link after that, and this link after that, and et cetera, et cetera. And basically what that algorithm is it's oversimplifying it a little bit, but at its heart, it's just doing a matrix with row operations, truly. It's solving a system of equations through a matrix like this. It's putting things into, row echelon form, reduced row echelon form. Now the difference is we're doing it with, 4 equations and 4 variables. Google does it with millions of pages and millions of variables, so it would be a much larger matrix. But that's really what it's doing. If we kind of shrunk down the internet to like 5 web pages, and I could give you guys a problem that's like, if someone searches this term, determine which page would be ranked the highest, what would be the best search result for them, and then the next best and the next best. Because you guys know all the operations that it does, right? Switching rows, adding columns, scalar row multiplication, things like that. So it's pretty interesting that just kind of some basic matrix operations and stuff is really what goes into like sorting the most powerful search engine on the planet. It's pretty cool. Again, the most impressive part probably is just that how big the matrix is that it's working with. It's not working with a 5x5 matrix. It's working with a 5 million by 5 million matrix or whatever. But at its heart, that's what it does. So you guys are mini Google search engines if you wanted to be. Yeah. Okay. I sent you guys an assignment that has practice with reduced row echelon form. It just gives you a couple systems. None of them are this big. None of them are even this big. I don't think. I'm pretty sure there's like 3 questions in there, and they're all 3x3 systems. All right, so it's still, still a lot of work, but it's not one of these huge, big systems. Kyler, are you awake now from that riveting math? Ha. Just a ha. Nothing more, nothing less. Ha. I feel awake. Okay. All right. Well, see you guys on Friday then. Would highly recommend doing some practice on some of those systems on that worksheet I sent you, or just some of the basic matrix operations at the end. Can you attend? Yeah, for sure. I'll approve that. And I'll see you guys back on Friday. Ending the week with some exciting stuff. Have a great rest of your day.